Hello friends, today we are going to be learning about mechanical energy. We're going to start on page 116 in our books, so why don't we turn to that page. In the meantime, let's think back to what we talked about on Friday. When we were talking about the different vocabulary words for this chapter, we learned that mechanical energy is an object's stored energy plus its energy of motion. So we're going to learn a little bit more about what stored energy and energy of motion are today. Alright, as soon as we get to page 116, we can start looking at the pictures, and we'll kind of notice that the picture on the left is a before it picture, and the picture on the right is kind of an after picture. So before we start reading, I want you to think about what happens when you sled down a snow-covered hill, like these kids in the photos in our book. It takes energy for you to move down the hill. In this case, gravity is pulling you towards the center of the earth, so you're going from a higher point to a lower point. But there's other reasons that energy can help us move, including like our muscles. Okay, so remember that mechanical energy is stored energy plus the energy of motion. So let's read our book. Our heading is Mechanical Energy, and our text says, "Look at the pictures below. The children ready to sled down the hill have a lot of stored energy. Stored energy is energy that is ready to be used. Look at the children sledding down the hill." So our little caption says, "These children have a lot of stored energy." So now we know what stored energy is. It's energy that is ready to be used. So that'll kind of help us understand mechanical energy a little bit better. Let's turn to page 117. And our text continues to say, "Their stored energy has turned into a new type of energy, the energy of motion. All moving things have the energy of motion. The mechanical energy of each child is their stored energy plus their energy of motion." And our caption on this page says, "The children have the energy of motion as they sled down the hill." So when they were waiting, they had stored energy, or energy that was ready to be used. But when they're actually moving, they have the energy of motion. Okay, I think that'll help us understand mechanical energy just a little better. So if I was holding a ball in the air, would that ball have energy? Well, yeah, it would, because all objects have energy. But what kind of energy does the ball have when it's in my hands? Well, it's got stored energy. It's ready to be used. The gravity is pulling on it, so it has energy. What other objects do you think could have some stored energy? Any of the objects around the classroom. Now, if I drop the ball, what kind of energy does the ball have now? Well, it still hasn't hit the floor, so the gravity is still pulling on it, which means that it still has more energy to use. But it also is moving, so it has the energy of motion. But as the ball falls closer and closer to the ground, the amount of stored energy it has lessens. There's less of it the closer it gets to the ground. Alright, so this combination of stored energy and energy of motion is mechanical energy. Well, that's pretty cool. Let's keep reading. Page 118 says, "Let's look at another example of mechanical energy. A skier starts at the top of a mountain. She has stored energy. She is not moving. She does not have any energy of motion. She's not moving at all, so all of her energy is stored." Well, that makes sense. Our caption here says, "Skiers have a lot of stored energy at the top of the mountain." Well, I guess that's because mountains are so tall. Okay, so now let's keep reading and see if we can learn a little bit more. Page 119 says, "Look at this skier. He is in motion. His stored energy changes to energy of motion as he moves down the mountain. The skier's stored energy plus his energy of motion is his mechanical energy." Our caption on this page says, "As the skier moves down the hill, his stored energy changes to energy of motion." But it's important to remember that he still has stored energy until he reaches the very bottom of the hill. So now if we look at page 118, and we look at the skier in that page, and then we look at page 119 and look at that skier, which of these two skiers has stored energy? Well, it must be the one on the left. And which one would have the energy of motion? Well, that must be the one on the right. But remember that the one on the right still has the stored energy as well, because he hasn't reached the bottom of the hill. So, what kind of energies make up mechanical energy? It's important that we remember that the two forces that make up mechanical energy are energy of motion and stored energy. Alright, so think about question number 2 on page 119. It says, "How is stored energy different than energy of motion?" So think about that for just a minute. Alright, and now we're going to think about number 3 really quickly. You are running down a hill. How does your energy change? So think about that to yourself, and then we'll talk about it in just a second. Okay, so when you start at the top of the hill, before you start running, all you have is stored energy. You don't have any energy of motion. But as you start running down the hill, your energy changes from only stored energy to energy of motion and stored energy. The closer you get to the bottom of the hill, though, the less stored energy you have. So that makes sense. Now, we're going to learn a little bit more about mechanical energy later today, but I want you to think about any questions that you have so that we can talk about them when we meet for science today. So you guys have all done a really great job listening. Make sure that you finish your 3-2-1s, and we'll continue science later. Have a great day, guys.